In this video, we're going to look at the relationship between the normal distribution and the standard normal distribution. We're going to start by covering the differences between the two things, and then we're going to have a look at the key questions that come up in this area of study. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The normal distribution is actually a term given to a family of functions that all have different means and different standard deviations. The standard normal distribution is just a normal distribution that has a mean of 0 and a standard deviation of 1. So because of this, all the methods that apply to the normal distribution also apply to the standard normal distribution. And for that reason, we're just going to focus on the unique questions that come along with standard normal distribution questions. The only other thing that you need to know before we start is that the standard normal distribution is often written in terms of z-scores rather than x-scores. The vast majority of questions that come up with the standard normal distribution are going to involve this equation here, which is actually a multi-purpose equation. In its current form, all we're doing here is converting our x value to an equivalent z value, as long as you know the mean and standard deviation of your normal distribution. But it also has another purpose, where it can be used to solve the statistics. This is because you can rearrange this equation to have any of the variables as the focus. So as long as you have 3 of the given 4 variables, you can solve for that fourth unknown one just by plugging in and rearranging for that variable. We're going to look at a few examples as to how this works. This question here tells us that we have a normally distributed random variable with a mean of 6 and a variance of 4. We're also given a related set of probabilities. One is written in terms of x, and the other is written in terms of z. We need to solve the value of b such that both of these probabilities are equal. A big part of these kinds of questions is to use the symmetry of the normal distribution to our advantage. The way it's currently written makes it very hard to compare the two inequalities. One is pointing as a greater than sign, and the other is a less than sign. So to make life a bit easier on ourselves, we're going to use the symmetry of the normal distribution to make sure that both of these inequalities are pointing in the same direction. If we do a rough sketch of our normal distribution, we see that x greater than 7 is just 1 unit to the right of the mean. So an equivalent probability would be 1 unit to the left of the mean, x less than 5. So what we can say is that the probability that x is greater than 7 is the same thing as the probability of x being less than 5. Now that the inequalities are pointing in the right direction, we can compare them much easier. The b value that we're looking for is a z-score, so it's going to go in the z spot. We've just found out that the equivalent x-score is going to be 5. We also know that the mean is 6, so the mean of 6 will go in that spot as well. The standard deviation we have to actually calculate. We were told that the variance is 4, and we know that the standard deviation is always just the square root of variance. So standard deviation is going to be the square root of 4, or just 2. After doing a bit of rearranging, we solve for b. I mentioned earlier that this equation was multi-purpose. It can be used to solve the statistics as well, depending on how you rearrange the equation. This one here has given us the mean and a relationship between an x probability and a z probability. What it hasn't done is given us the standard deviation. That we need to solve. As before, we're just going to rewrite our inequalities so that they're pointing in the same direction. Technically, you can do either side of this equation, doesn't matter which one you try to simplify. My preference would be to simplify the z version of it, since there's an opportunity to reduce the complexity. Graphing the standard normal distribution looks like this. When we do that, we can see that saying 1 minus the probability that z is greater than 1.5 is the same thing as just saying z less than 1.5. So let's just say that instead. Much easier to compare. From here, we can see that the z-score must be 1.5, and the x-score must be 259. We were also told that the mean was 250. That leaves the standard deviation as the only unknown in that equation left. So to solve for it, we're just going to rearrange to get the standard deviation on its own, and then just simplify the equation. That's pretty much all there is to these kinds of questions. Whenever you have a standard normal question, the vast majority of the time, you're going to be using that conversion formula. And all you're going to do is plug in all of the known elements in that equation, and then solve for the one that's unknown. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge, so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.